What's up, guys? Let's take a look at day 4 of Advent of Code. This one's called Series Search, and that's series with a C, like the Roman goddess or the planet. Our theme today is a word search. We've got the word Xmas appearing up or down, left or right, or diagonal, either way. This can overlap, so if we find a letter contributes to one instance of Xmas, it's still active in order to contribute to others that might use the same spot. So this visualization gives us a little dot of the ones that don't contribute to any, and then we can see like, oh, there's an Xmas, and there's a diagonal, and there's a diagonal going the other way. In total, that's 18 for this example. So these kind of problems are usually annoying when you get to the edges and you try to find the neighbors, and oops, you've gone off the deep end. So for this, we're going to start by making a dictionary. We can give it a tuple of X and Y, or R and C, row or column. This is inspired by Reddit user 4HBQ, who had a nice post that I saw today when I was showing somebody how nice the Reddit is for Advent of Code. So let's see what we got here. We've set ourselves up with part 1, part 2, read the file, and that's it. So let's give it a shot. I'm going to make a little lookup, we'll call it. It takes the lines, which is a list of string, and it returns a dict of tuple int, which is our point, our coordinate, to stir, which is our letter for a spot. By the way, the data is pretty big. It goes to 140 squared, which is like almost 20,000. Now, let's see. I know this is very ugly, and we can give that a type alias in just a minute. Let's say return RC to char, maybe, for R row and enumerate lines, for C char and enumerate the other thing, and let's print that to make sure we're not too far off. Oh my gosh, that's the big data. I want to test it on the example. Let's say, hey, we've got this, still pretty ugly, and we're not going to get much help today from printing because everything is too big, or it's just not the kind of visual that would help. But we do see like 00 is M, 01 is also M, which is what we find in our example text. So now we can look that up. Let's give it a name. I'm going to call it, well, let's give it some types first, okay? So I was watching somebody do Advent of Code in Rust, and I was jealous of all the types. And it's almost like once you set up what's coming in and out of the functions, you're done. There's hardly any other job after that. So let's say point is, if I could type, a tuple of int, and then we can put that in here. And then we'll call it space is this thing, and then we'll put that here. So now I can use that for this function. I can use it for other functions, which are going to take points and spaces. And maybe I can use it in the future, because it's a good bet that some Advent of Code will also be grid-based, and we have to worry about going off the deep end later. Now, how can we use it? Well, these guys are now going to take spaces because we've already done the parsing. And they still return ints, which is fine. Now we're going to say space equals lookup lines, and then we do that with space. Okay, I suppose there might be a 3D space later. Who knows? We could also use a default dict, and that would be nice because we set the default, like, hey, we're giving strings, so maybe we should make it an empty string. But that's not a problem. We'll handle that when we get to it. So let's say part 1 and part 2, what are we doing? Well, I'm getting the feeling that I want to offset one layer of it into another function, and then part 1 is like some map, whatever. Just like we've done in the last few days, it's very nice instead of trying to do everything all in one with nested for loops or nested anything. So let's say, okay, what are we going to call this thing? I'm going to have a little note over here because I don't want to make any mistakes. Xmas will be the thing for part 1 where we like get a point and we look at the possible Xmas's around that point. And you know, in previous days I had reading the file up at the top and I was treating it kind of globally, but now we're going to pass it in, do it right, okay? And that'll probably return a bool, and then we'll do something with it, and then we'll return like sum of Xmas for point in space. And so then we don't have to handle every dimension all at once. We can handle just like a single point, which is still a lot of stuff coming out of there for each one. So first we're going to go destructure the point to R and C because we're going to use it for our ugly R plus whatever, C minus whatever stuff. And then we're going to say like, okay, I need my directions. I need left, right, up, down, whatever. And so that's like negative, 0, positive. But we're doing 2 at a time. So it's like up left, down right, whatever. So instead of just 1, I'm going to go from itertools import product. So we can do like all the combos of like -1, 1, 1, -1, 0, 1, all that stuff. Product of this with, I think they have it called repeat, which is like comboing with itself. You know, you could imagine rows and columns and like find all the different, you know what I'm saying. And then we've got our target, which is like list of Xmas. This is another thing that I took from good old 4HBQ, who was looking for these things after a big ol' ugly comprehension. We don't want to have to join that back into a word or type out these things, so we just say list of the word and it'll do it. So beautiful, that's great. So we're going to go list of Xmas is like our target, our thing we're looking for, and then we're going to return space dot get something for something equals word, because we're going to like go off in one direction and see if that equals XMAS, and then we'll go off in another direction and see if that equals XMAS for dr, dc in directions. So that's like your differential or your delta. Like in calculus, you have dy dx. Dr, dc is like the offset, or really not the amount, but just the direction. So here's what we're going to do. We're going to go r plus dr, and then c plus dc, but that's only where we're pointing. So that's like, hey, we're pointing up and right or down and nothing. And then we have to stretch it. We have to say, okay, well, now that I'm pointing that way, I need to go 1, 2, 3. So we're going to go times something for in range 4. Is that right? And then we're going to say, well, hang on, that's not a bool, that's a list of bools. Okay, sure. Which means I can't do this anymore. Okay, fine. I get a type error. So I can say, hey, what have I been doing recently? itertools, isn't there something for that? Uh-oh, what's this? I need to give it a tuple, not give it 2 separate things. So now we're going to say, okay, how can I do this? Could I sum map? Sum, yes, that's annoying. Could I flatten? Could I Well, ItterTools has a thing called chain, which is pretty good. Chain on its own is for, well, I don't know if that works. Let's see. Okay, yeah, beautiful. 18 was the sample answer here. Great. The problem with this, and I mentioned earlier, is that it's hard to print. It's hard to say like, oh, here are the diagonals, because you don't really see that they're diagonals. You just see XMAS, and you just have to like hop back over here and see, is that right? But this is the starting point plus the direction plus the extent. Like, oh, we're here, we're pointed that way, and we go that much. And that's why it has to be so ugly. Now, part 2, or let's try it on the big data. Let's say data, and you get, oh, it takes a second, but only a second, maybe 2. 2543, was that the answer? Yeah. So now part 2 says, hang on, it wasn't an Xmas puzzle, it was an Xmas puzzle. So it was MAS in a cross shape. So like MAS, or it could have been SAM, meaning we're looking for a slightly different thing, but it's basically the same idea. We go to a point, we look at its neighbors in a certain direction, and we see. Now, in this case, we have to find 2 things, like an MAS and an MAS, or a SAM and a SAM, but it's still kind of the same idea. So what are we going to do? We're going to copy paste. I'm going to say, hey, this Xmas is going to be the engine for part 2, except it's an X_miss. We still get the point. The direction, well, for this one, we're just going to have like 1. And then the word, well, we're going to have 2, because it's like list of Moss and list of Sam. So the way we're going to do this one is like 2 separate things, where it's like, is the uphill Moss or Sam, and is the downhill Moss or Sam. Okay, so this part's going to be different, equally ugly, but a different kind of thing. So we're going to go space.get something for the in directions in words. So like it could be Moss or Sam going uphill, and it could be Moss or Sam going downhill. It's fine. Any combo of those is fine. And so what is this? Well, we're going to go R plus D and C plus D. So it's like one constant move, like the D in directions as we're going that way or that way, which is how you get diagonals. And I think we need to wrap that in another little thingy. And I put singular this time, I don't know. And then this one, that was like the uphill, theoretically. And then this one's just going to be the same with a minus to go the other way. Okay. And then here we're going to say, wait a minute, that's not list of bools, that's just a regular bool. And then this we're going to go sum. I wanted to say map, but we can't because it's 2 parameters. And then 1930. We didn't try it on the example. Let's try it on the example. It was 9. Okay. Which is a little misleading because they have half as many, but you know how some of them you can tell that part 1 is going to be more and part 2 is going to be less because part 2 is more restrictive? Or on some of them you can tell that like part 1 was very straightforward and part 2 is more forgiving. It's like, oh, what if you tolerate more deviation? And then you know that part 2 is going to be a higher number. In this case, I don't think we can know. I think we can guess that it's going to be around the same amount. So there's less of a hint. We can't say like, oh, our number was bigger, therefore it's not right, and we have to try again. I think our number could go either way. So It turns out if we do it on the big data, it's like kind of the same-ish. It's in the same neighborhood magnitude of 1930. Was that it? Yeah. So what did we learn today? 1, guys on the Reddit know what they're talking about. 2, I watched a person do this in Rust, or not today's, but another day, and I was jealous of the type hints and type aliasing and type, new types. We haven't done any enums here, but enums are great. So I just wanted to say that, like, hey, if I use space, I want it to be a space and not an ugly dictive tuple int to string. And then in the future, we might do similar ones or exactly the same ones, maybe. I've also got a little more organized with my main function and a little more organized with these, even if they're still quite ugly. Like this one I'm really feeling bad about because it stretches very far, and I don't like to go that far. I think 80 is the classic limit, and this goes farther than that. But anyway, fun stuff, like tic-tac-toe, but big. In fact, that is one of the classics, like tic-tac-toe, is where you learn to do diagonals, right? Did I already say that? I don't know.